Good afternoon, ladies and gentlemen. I am glad to participate in this conference. For your attention, report on the topic Application of Polarization-Time Model Seismic Signal for Remote Monitoring of Potential Source Emergency by Three-Component Seismic Station. Emergency events are becoming more global as the population grows and people live in dangerous places. Ukraine is no exception. So there is a need for a system to detect hazards at their inception, especially in high-risk areas such as seismically active zone. Ukrainian civil protection system is established to prevent and eliminate the effects of emergency, warn population about threat and protect them from their effects. Timely information about emergency is critical, which is why emergency monitoring system is used. Seismic monitoring is fast and allows for remote monitoring. Main center for special monitoring providers seismic information for Ukraine and neighbor countries. Seismic data is processed both manually and automatically. Decisions on seismic event parameters and its possible impact are made by the operational duty officer of Main Center for Special Monitoring based. Analysis of information received from each observation point. Initial information on the event parameters and potential impact can be provided in 15 minutes and final information within 40 minutes. Monitor can be improved by upgrading equipment and switching to digital data processing, but the limitation is the manual processing of seismograph, which limits the speed of providing information to users. Literature review. This slide presents the application of various seismic data processing methods to detect potential source of disasters. In practical, it is pointed out that in Ukraine, a polarization analysis apparatus is used to characterize seismic signal, as well as the method of controlled direction reception to detect seismic signal in the region of the formed beam. However, none of these methods allows to release continuous monitoring of potential source of emergency events. The aim of this work is developing the methodological principles for the implementation of continuous remote monitoring of potential source emergency based on the results of observation of a three-component seismic station taking into account kinematic and dynamic features. Possibility of continuous monitoring potential source of emergency is based on seismic signal components that match practical types of seismic waves and their parameters. After epicenter of seismic event, elastic ground vibration spread in all directions and a source information for identification of seismic event and estimation of its parameters. Seismic waves can be bulk PCS waves or ground, rail, and lava waves. To indefinite the center of seismic event, it is enough to operate only with bulk seismic waves, since ground waves are registered in the tail part of bulk waves, which makes them difficult to determine. For each bulk waves during a seismic event in a regional zone, the coordinate characteristic will depend on the position of the cell relative to the observation points and three-component seismic station. For a P wave, the angular characteristic will be same as the position of the sail, and for an S wave, they will differ by 90 degrees from the angular characteristic of the P wave. In order to monitor a potential source of emergency, it is necessary to know position of monitoring object relative to three-component station, which will allow us to determine angles of seismic wave arrival as the ground surface from event and time difference between the seismic signal components. This slide proposed to use polarization time filtering based on the model of the expected seismic signal for continuous remote monitoring of potential source of emergency. To form the model requires the angular characteristic of P waves and the distance to monitored object. This model takes into account dynamic and kinematic future of seismic signal from source in the regional area. We proposed to define a degree of seismic signal linearity and correspondence to the direction of seismic signal components output to the ground surface by relating the projection of ground vibration on the selected direction to the total ground particles displacement. This slide presents results of the application proposed approach for detecting seismic signal from Chernivtsi and Branch regional zone, were analyzed using a polarization time model. The model parameters were determined based on the distance, epicenter, and the seismic wave surface arrival angles. The maximum of the solving function corresponds to the first P waves arrival for both regions. The proposed approach proved successful in detecting seismic signal from potential hazard areas and can be used for continuous remote monitoring. In this work, we analyzed seismic signal from event with force in a regional area and established the relationship between the signal characteristics and the position of the focal point relative to the observation point. It is proposed to use polarization time model to monitor potential source of emergency event using a three-component seismic station. Results of applying the proposed approach to detect seismic signal from earthquakes in regional area indicate its relative ease and ability to implement monitoring in a time mode close to real time. The application of the proposed approach makes it possible to reduce the time for detecting an emergency event within the territory of Ukraine from 15 minutes for 3 minutes. Parameters of the polarization time model for nuclear power plants and hydraulic structures of the Dnipro Cascade, which are the most dangerous object and present. Future research is focused on the development of theoretical foundation for seismic data processing to help identify the nature of the seismic source, forming a database of polarization time model and studying variations in seismicity models for the repeat detection of emergency event. Thank you for attention.